So, what is sedimentary cycle? Sedimentary cycle is a fundamental geological process encompassing the sequential stage of sedimentation, transportation, compaction, and lithification. Serves as a dynamic archive of Earth history, intricately preserving a rich tapestry of environmental, climatic, and biological changes over a million of years. This cycle not only contributes to the formation of diverse sedimentary rocks formation, but also plays a pivotal role in sustainable provision of essential resources vital for human civilization, including fossil fuels, minerals, and groundwater, while serving as a reservoir of invaluable fossil records that offer profound insights into the past ecosystem and evolutionary pathways, thus facilitating a deeper understanding of our planet's geological heritage and informing critical decisions regarding resource management,
The phosphorus cycle is a
environmental
biogeochemical cycle that
conservation,
describes the movement of
climate
phosphorus through the Earth's
mitigation
lithosphere,
strategies
hydrosphere, and biosphere.
that is sedimentary.
Phosphorus is an essential nutrient for all living organisms as it is a key component of DNA, RNA, and ATP, which are crucial for cellular structures and energy transfer. The cycle begins with weathering of rocks, releasing phosphorus into the soil and water. From there, plants absorb phosphorus from the soil through their roots. Animals obtain phosphorus by consuming plants or other animals. When plants and animals die, phosphorus is returned to the soil through decomposition where it can be reused by plants or leached into in aquatic ecosystem. Phosphorus can cause eutrophication, a process where excess phosphorus leads to algal blooms and subsequent oxygen depletion, harming aquatic life. Human activities such as agriculture and the use of phosphorus-containing fertilizers can significantly impact the phosphorus cycle by altering its natural balance and contributing to environmental issues like water pollution. Overall, the phosphorus cycle plays a crucial role in sustaining life on Earth and maintaining ecosystem health.
How is the sedimentary cycle and phosphorus cycle connected? Well, in the sedimentary cycle, rocks break down into smaller particles over time due to weathering and erosion. These particles eventually settle and form sedimentary rock layers. Now here's where it gets interesting. Phosphorus, a vital nutrient for living organisms, is found in these sedimentary rocks in the form of phosphate minerals. When these rocks weather and erode further, they release phosphorus into the soil and water, where it becomes available for the plants to absorb. As the plants grow, they take up phosphorus from the soil, incorporating it into their tissues. When animals consume these plants, they acquire phosphorus, thus completing the cycle. And so, the sedimentary cycle and the phosphorus cycle are intricately linked as phosphorus moves through the Earth's crust, soil, water, plants, and animals in a continuous loop, sustaining life on our planet.
Now, how do humans affect the sedimentary cycle? There are various ways wherein humans directly impact the sedimentary cycle. The first one is mining and quarrying. Humans extract vast amounts of sedimentary materials such as sand, gravel, and limestone for various applications such as construction, agriculture, and industrial purposes. This extraction of materials alters the natural sedimentary deposition rates and leads to habitat destruction and erosion. Second is deforestation. Natural sedimentary processes are disturbed when forests are cleared for logging, urbanization, and agriculture. In order to stop erosion and sediment runoff into oceans and rivers, tree roots help maintain the soil. However, the removal of forests modifies the patterns of sediment movement and accelerates erosion. Then we have the construction of dams and reservoirs. River sediment flows is altered and downstream sediment transport is decreased by the construction of dams and reservoirs. This disturbance may cause aquatic ecosystems to suffer from a lack of sediment, change the patterns of coastal deposition, and cause sediment famine in places downstream. However, humans could still care for the sedimentary cycles through the following: sustainable mining practices. Reducing the negative effects of mineral extraction on the environment is a key component of sustainable mining methods. This entails cleaning up regions that have been mined, lowering pollution caused by mining, and encouraging ethical procurement of sedentary materials. Afforestation and reforestation. Restoring forests and planting trees contributes to soil stabilization, decreased erosion, and the preservation of natural sedimentation processes. The regulation of sediment movement and deposition rates are largely dependent on the health of the forest. And finally is the integrated watershed management. Coordinating land use, water resources, and conservation initiatives is necessary for the implementation of integrated watershed management strategies. By maintaining healthy aquatic ecosystems, reducing erosion, and safeguarding sediment supplies, this strategy is deemed effective for the overall preservation of the health of the entire sedimentary cycle.
Human activities have significantly impacted the natural flow of phosphorus in the environment. So, let's discuss what key human activities do to disrupt the phosphorus cycle. First of all is fertilizers. A major influence comes from fertilizer used in agriculture. These fertilizers are rich in phosphorus, and often excess amounts not absorbed by plants get washed away by rain into rivers and lakes. This runoff creates an abundance of phosphorus in the water, leading to a phenomenon called eutrophication. Now that we've mentioned eutrophication, let's explain what it is. Eutrophication is the excessive growth of algae caused by high nutrient levels in the water. While phosphorus is a vital nutrient, too much of it disrupts the natural balance. Algae blooms deplete oxygen level in the water, harming aquatic life. The next one is the mining and transportation. Phosphorus is mined from rocks and converted into fertilizers. This mining process itself disrupts the natural distribution of phosphorus. Transportation of fertilizers and agricultural products further affects the cycle as well. And last but not least is wastewater. Improperly treated sewage can also release phosphorus into water bodies, contributing to eutrophication. The consequences of human influence on the phosphorus cycle are far-reaching. It can harm aquatic ecosystem, disrupt food chains, and limit clean water resources.